Nitric acid, also known as aqua fortis and spirit of nitre, is a highly corrosive mineral acid. The pure compound is colorless, but older samples tend to acquire a yellow cast due to decomposition into oxides of nitrogen and water. Most commercially available nitric acid has a concentration of 68% in water. When the solution contains more than 86% HNO3, it is referred to as fuming nitric acid. Depending on the amount of nitrogen dioxide present, fuming nitric acid is further characterized as red fuming nitric acid at concentrations above 86%, or white fuming nitric acid at concentrations above 95%. Nitric acid is the primary reagent used for nitration, the addition of a nitro group, typically to an organic molecule. While some resulting nitro compounds are shock and thermally sensitive explosives, a few are stable enough to be used in munitions and demolition, while others are still more stable and used as pigments in inks and dyes. Nitric acid is also commonly used as a strong oxidizing agent. Commercially available nitric acid is an azeotrope with water at a concentration of 68% HNO3. This solution has a boiling temperature of 120.5 degrees Celsius at 1 atmosphere. It is known as concentrated nitric acid. Pure concentrated nitric acid is a colorless liquid at room temperature. Two solid hydrates are known, the monohydrate and the trihydrate. An older density scale is occasionally seen, with concentrated nitric acid specified as 42 degrees Baum. Nitric acid is subject to thermal or light decomposition, and for this reason it was often stored in brown glass bottles. This reaction may give rise to some non-negligible variations in the vapor pressure above the liquid because the nitrogen oxides produced dissolve partly or completely in the acid. The nitrogen dioxide remains dissolved in the nitric acid, coloring it yellow or even red at higher temperatures, while the pure acid tends to give off white fumes when exposed to air. Acid with dissolved nitrogen dioxide gives off reddish-brown vapors, leading to the common names, red fuming nitric acid, and white fuming nitric acid. Nitrogen oxides are soluble in nitric acid. Commercial-grade fuming nitric acid contains 98% HNO3 and has a density of 1.50 grams per cc. This grade is often used in the explosives industry. It is not as volatile nor as corrosive as the anhydrous acid and has the approximate concentration of 21.4 m. Red fuming nitric acid, or RFNA, contains substantial quantities of dissolved nitrogen dioxide, leaving the solution with a reddish-brown color. Due to the dissolved nitrogen dioxide, the density of red fuming nitric acid is lower at 1.490 grams per cc. An inhibited fuming nitric acid can be made by the addition of 0.6 to 0.7% hydrogen fluoride. This fluoride is added for corrosion resistance in metal tanks. The fluoride creates a metal fluoride layer that protects the metal. White fuming nitric acid, pure nitric acid or WFNA, is very close to anhydrous nitric acid. It is available as 99.9% nitric acid by assay. One specification for white fuming nitric acid is that it has a maximum of 2% water and a maximum of 0.5% dissolved NO2. Anhydrous nitric acid has a density of 1.513 grams per cc and has the approximate concentration of 24 molar. Anhydrous nitric acid is a colorless mobile liquid with a density of 1.512 grams per cc that solidifies at -42 degrees Celsius to form white crystals. As it decomposes to NO2 and water, it obtains a yellow tint. It boils at 83 degrees Celsius. It is usually stored in a glass shatterproof amber bottle with twice the volume of headspace to allow for pressure buildup. But even with those precautions, the bottle must be vented monthly to release pressure. Two of the NO bonds are equivalent and relatively short, and the third NO bond is elongated because the O atom is also attached to a proton. Nitric acid is normally considered to be a strong acid at ambient temperatures. There is some disagreement over the value of the acid dissociation constant, though the pKa value is usually reported as less than -1. This means that the nitric acid in diluted solution is fully dissociated except in extremely acidic solutions. The pKa value rises to 1 at a temperature of 250 degrees Celsius. Nitric acid can act as a base with respect to an acid such as sulfuric acid. The nitronium ion, No+2, is the active reagent in aromatic nitration reactions. Since nitric acid has both acidic and basic properties, it can undergo an autoprotolysis reaction. Similar to the self-ionization of water, nitric acid reacts with most metals. But the details depend on the concentration of the acid and the nature of the metal. Dilute nitric acid behaves as a typical acid in its reaction with most metals. Magnesium, manganese, and zinc liberate H2. Nitric acid can oxidize non-active metals such as copper and silver. With these non-active or less electropositive metals, the products depend on temperature and the acid concentration. For example, copper reacts with dilute nitric acid at ambient temperatures with a 3:8 stoichiometry. The